Alright, welcome to another tutorial. My name is Merunas. I'm the founder of Yield Finance. I'm an author of 2 Ethereum books. I write articles, I create YouTube videos, I do pretty much everything. And here, this video today, we're gonna learn how to use the API of DeFi Yield. This right here. So DeFi Yield is a company, let me show you. It's a company that allows you to see all your assets. It's a dashboard, a DeFi dashboard. You can access your assets and see how much of everything you have on every blockchain. They have like 35 blockchains scanned, and they allow you to do many different things when it comes to DeFi. And today we're gonna build a dashboard using their API. As you can see here, the API allows you to access the different chains, different assets, and the most important thing, the asset balances. We are going to use the asset balances to check how much of each coin you have and many different things. We're going to build a DeFi dashboard, this one. As you can see, it's a very simple application. The design can be customized, but I made it simple in purpose, intentionally. And the way it works is you disconnect your wallet. You go to MetaMask or any other wallet. You choose the account. You click on Connect Wallet. It shows a wallet connector. You can choose different wallets. I will choose MetaMask. And once connected, it communicates with the server. Wait, let me start the server first, because we need to run the server in order for this to work. It recognizes the account since we are connected already, and it's loading the assets. This takes a while because there are many blockchains. There are 35 blockchains, and we're checking how many of each asset you have on every blockchain. I'll go into detail later on, but first let me show you how this looks like. It's making requests, as you can see. Let's wait for this to load and show exactly how this looks like. I'll explain you later what we're trying to solve, what problem we're solving here. But first, let me show you how this looks like, just so you get an idea of what we will achieve by the end of this tutorial using DeFi Yield's API. This API allows you to create many different applications. In this case, we're going to build a DeFi dashboard. As you can see, it shows you the different assets on the different blockchains, grouped by every coin. As you can see, ETH, we have that many ETH on Ethereum, on Arbitrum. You see, the goal here is show all your assets for this account on all the different blockchains and grouped by assets, so you can see all the blockchains in every asset. Okay, let's explain the API. The API is a very simple API. You have all these possible queries, and you authenticate to the API to then request whatever information you want. It has a cost. You see there's a cost for a query. The asset balance is the one we're going to use. It has a cost of 10 credits. There is a limit to 10 queries, 100 queries per minute, or 20 if you're using asset balances. Just keep that in mind. So just so you can see how this looks like, let's go to the playground, and here you can interact with the GraphQL database. You set up your API key. I'm using a test API key right now, and I have a query. Let me remove this for now. We are simply requesting the chain's name and ID. You can write down absolute chain ID, which is the original chain ID. ID is the number sorted out in DeFi yield. So in reality, the ID of this of Ethereum is 1, of Binance is 56, but on DeFi yield is sorted by the number 2. That's the way they're sorted. You see Polygon, the chain ID of Polygon is this one. We're gonna use this later on. I'll show you how. And more importantly, we are gonna access the asset balances. So you can specify, if I want to access the assets on Polygon, I go to the ID here, 3. You gotta use the ID 3, not the absolute ID. And the wallet address. We are gonna access the assets. And for every asset, get the name, chain ID, and symbol. Then the balance for the asset. As you can see, assets, we got the name, different coins. You have this many, Polydoge, the symbol, the balances of all the different assets on the chain 3, which is Polygon, if you remember. And we have all the different ones here, or the different blockchains. So yeah, that's how you interact with the API. You can, like I said, go to this link, authenticate yourself with the key, and then you can do all the different things. Now, in order to get a key, you gotta get request one here. As you can see, it says here. Simply go here and you put your name, subject, and all different things. Simply request the public API key and you will get it very soon. Alright, so that's when it comes to the API. Let's go ahead and set up the project. Before going to the setup, I'll show you the plan. So here's what we're doing here. Problem. We are solving a problem. In this case, we are trying to see how much Ether do I have across all the different blockchains. So you can have Ether on Polygon, on Binance Smart Chain, on Ethereum, on Arbitrum, on Optimism. All the different blockchains have their own, the same Ethereum, right? It has the same Ethereum. So I want to see how much Ethereum I have across the different blockchains, sorted out, grouped by the blockchains. Same thing with Matic and all the other coins I have. The solution is create a dashboard with DeFi Yields API to check how much of each asset is in every blockchain grouped by symbol. So yeah, this is a very simple explanation. The idea is to show this, which, if you remember, is exactly what we achieved here. You see the assets and the blockchains with the amount stored on each blockchain. And we are gonna create this object on the server. We're gonna sort the information this way so that we can access it. All right, let me start a new project. Even though I have the project here, I'm gonna start from scratch so you can see how it's done and you can follow along. I'm gonna go to open folder, go to my desktop and create a new folder called my dashboard. It's an empty folder. Now I'm gonna go to my terminal, cd does desktop my dashboard. I'm gonna initialize npm and I'm gonna install a few things. Well, I don't recall exactly which ones. Let me check. We're gonna need the following. I'm gonna use yarn to add bubble / core bubble preset env bubble register DeFi yield dash app / SDK wagme core. We will need this. I'll show you why later on. Web3 model core. By the way, the model is this thing that shows the selector of the blockchain that you want to connect to, so that you can use MetaMask and all the different wallets. That's the model, the Web3 model. Then we need Web3 model Ethereum, Web3 model UI, We need EGS. We are going to use that for generating the page. We need ethers, no express, nodemon, npm run all, tslib. Well, not sure about that one, but we'll add it. web3 model. Let me install also webpack and webpack CLI. Yeah, I know it's a lot of things, but you'll see that it makes sense in a moment. Once everything is installed, we're gonna start coding the server. So let's create a new file called start.js and another one called server.js. Why do we need two files? Well, because we want to use imports, specific imports. So the first thing we're gonna do is we're gonna use the Babel register. This is a little trick I've learned. Babel register. You're gonna see in a moment why I'm doing this. Require server. Then we create a Babel dot Babel rc, and inside, wait a moment, we write down a JSON that says presets Babel preset emp. Let me see if the install is in progress yet. Okay, now in server, now that we have done this, we can write the code in server, and we are able to use imports like this. Express from. I don't know how these are called compared to these ones. You see, these are different types of imports. They accomplish the same thing, but these ones are the modern way, and the only reason I set up everything with Babel is so that I can do this here. It's very simple. You just need to do it once, and then you're gonna be fine. So before doing anything, let me console log setup so that we can actually see if this is working or not. Okay, the installs are finished. Let's go to package.json and create a few scripts. The first one is gonna be called server, and it's gonna be npx nodemon start.js. We're running the start file, which calls the server file with Babel, so that all the imports are processed properly and they're working. So once we have server, we go to this and do yarn server. It's running npm nodemon, npx nodemon, so that it refreshes when we make changes. And you can see the console log here, the setup, which means it's properly set up. So let's start working on the server. The server, if you remember, let me open up. Okay, so what I did here is I simply took the plan txt document and I added this to the folder. So yeah, what the server should do is it should create this thing, this configuration of assets, so that it sends that to the client, to the website, and it's shown properly to the users. Okay, so yeah, we're gonna start working on that. First, let's set up a server with Express. Const app express const port equals 8000 app.set view engine. That's why we installed EGS, because we're going to use it. App.use express.static dist. I'm going to use webpack. That's why we need to set up a static folder. Okay, now we are gonna set up a logger, a middleware, this will log every request so that we can see what's been requested. Use the next keyword, the next function. We're gonna get the time, new date, console log. Okay, by the way, I'm just copying the previous code so that we go faster. And this is what we are gonna show to the user, to the server owner. Original URL at the time.get hours colon time get minutes function colon time get seconds. So yeah, this will be logging every request we make, and then we set up the server. Listen, port 00, so it's available locally. We use 000, and then we log the server. Listening on a local host port. Okay, now that this is set up, we can go to here and do yarn start or yarn server. Yeah, as you can see, the server is started and every request. Let me show you Postman. Let me prove that every request is being logged. This takes a while. I'm gonna make a simple call and show you that it's actually being shown here. If this connects today, you see a localhost get to call to test. We send that, and we get, you see, get to test at the time. Let's close this. Now we stop the server, and yeah, let's continue working on this. We need to set up thinking about a few things. We need to set up Webpack. We're gonna use Webpack because we will use imports for specific node modules, and that requires Webpack. So let me go ahead and set up that. Import the path first. Path. And Webpack is pretty simple. You just set up a very simple configuration mode, development, so that it goes faster. Entry. We're gonna set up a source folder, and inside the source folder we're gonna have an index, which is the frontend index, and that's gonna be, well, let me use path.join their name source index.js. The output is gonna be file name build.js, and the path.resolve their name. I'm gonna use this. Well, use join. So that way we are taking all the front-end JavaScript and combining it into one build file with all the configurations and all the imports. Great. Now what else? Let's start with the server coding. We are gonna create a function that does basically this thing here without the chains. We're gonna create a function that makes a request to the API with all the different parameters, or these parameters, and we are gonna we're gonna try to see if that works. All right, so let me go to the server. Let me comment out the server so that it doesn't start yet. I'm gonna create a function and we're gonna call it get asset balances. It's gonna be an async function and it's gonna require a wallet address to check. Yeah, we're gonna run this function right as the server starts, just to try it and make it work, to test it out, because first when you work on something you need to test it and make sure it works. Then we import create client from DeFi yield. We are gonna need DeFi yield to access all the information they provide to through the API. Once we have that, we need a few things. We need the API key and we need the API URL in case it changes in the future. The API, if you go to the docs, the API URL is this one. You add that as a string, and the key, I'm gonna use this is a test key. It has no limitations as far as I know, but if you are doing a serious project, you need to create one yourself, like I explained earlier. Put that down here. Let me copy that. See, okay, that's the API key. All right. Oh, by the way, you need to include GraphQL. That's something I got confused with that earlier, and I spent some time trying to fix it. So this is important. You need to include GraphQL at the end. Now, the first thing you need is to create the client. Create client. URL, we are going to use the API URL, and the headers are going to include this thing here. X API key, like that. I'm going to pass our API key from here. Okay, the client is created, and let's try to make a request like this, chain ID 3, and with that wallet address. In order to do that, let me check. We're going to use the query function. Let's call a result. And yeah, we're first trying to get a request and see if that works, and then we are going to format it properly. Client.query. We are simply requesting the asset balances. Remember, we want to access the asset balances. And as you can see, we're passing two parameters. We need these two to let the API know which chain ID and which wallet address we are interested in. In order to pass parameters, you need an array here. The first item of the array are the parameters, and the second item of the array are all of these selections. So it's an object. Let me start with that. It's an object, and it's gonna be chain ID. And remember, this needs to be a number, an integer. It cannot be a string. So we're gonna do 3, and the wallet address, I'm gonna use this one here. You can use your own just to see that it works. And then as the second parameter of the array is the selections here. It's very simple, very similar to what's shown here in the playground. You simply select the asset. By the way, when you're playing around, you can check out all the properties you see. Asset balances, you have assets, and then all the different parameters here. That's how I got this query. That's how I made it. So we want to access the asset, then that contains the name, we use true. As you can see here, there is no true, but we use true because we need chain ID, true, and symbol. We're gonna need all of those. And then balance, that's how much of that particular coin you have on that blockchain, on the blockchain number 3, which is Polygon in this case. So let's log in the result and see if this is working or not. Let's make some messages, make inquiry. Let's do that. We start the server and we should see all of this here. I don't know, this is something they need to fix. It's a warning, so it's not application. You can see we get the result, we get the data, the asset balances, and the assets. Now, as you can see here, it shows array. That's because they don't want to show everything. So we simply do JSON.stringify. No, that's not the way. I forgot. Well, we simply access the property data and asset balances. I'm gonna do that again just to show you that we're getting the result. We need to move fast because there's a lot of steps to complete this application. So you can see we're interacting with the API, we're making a request, and we're getting all the information that we requested. The object here is containing all of these properties that we selected earlier. So yeah, now, as you can see, we are getting the result that we want. Now, if you remember, the application we built is reading all the different assets to this account and all the blockchains those assets are located into. So we need to go through every blockchain and we need to go through every asset. As you can see here, we are making a request to the blockchain 3 and we're getting all the assets that has a balance. So we now need to loop through all the blockchains. In this case, the blockchains that are available here. As you can see, chains. If we make a request, you will see that all the blockchains are these ones. We simply remove the absolute chain ID because we don't need it right now. So what we're gonna do is we're gonna take the chains here, we're gonna copy all of this into an array, and we're gonna remove line break remover. We're gonna remove the line breaks so that we can add it to the code easily. We paste this, remove line breaks, and we copy this. Now we have all the blockchains with the IDs. You can make a loop through to the number 35, but this way is more professional. So we're gonna do chain IDs. I'm gonna put that, wait a minute, this is an equals, there you go, chain IDs. I'm gonna do this. Alright, what next? Now that we have the chain IDs, we're gonna create a few helper variables. Well, let me keep the console log just in case to show that we are actually making a request. And we are going to create a few helper variables. Assets found, that this will contain an array of all the assets sorted properly, and asset names found. This is an array that contains all the asset names. In this case, it will contain, A, USD, Chai, IOV, ETH. The names of all the assets that have been found so far. This will be important later on. I'll show you how and why. So yeah, let's create a for loop. But wait, let me check this. Okay, let's create a for loop. I like to use the traditional syntax for the for loop. chain IDs, wait a minute, IDs dot length I plus plus. All right. Now we are looping through all the blockchains, all the chains compatible with this API, which is pretty much everything, because 35 blockchains, they have 35 blockchains available. It's a very, very extensive API. Now we need to modify this so that instead of using this, we're using the chain IDs here. So we go chain IDs I.id. We're accessing the ID here, and we're gonna use this function with this parameter because we will need it later on. All right, now we are making the same request, and we're gonna check a few things. This is a bit of a confusing step, but you'll see how it works. So if result the data, this means if we are getting some data, and if the result of data dot asset balances is there, and if result dot data dot asset balances dot length, well, dot assets dot length, this is in case we are getting empty responses, because sometimes you make a request and you get no assets because you don't have any asset on that blockchain. This is why we need to use this check to make sure there are assets there. And if, yeah, I'm gonna create a helper variable here called selected, and we are gonna get result.data.asset balances.assets. Okay, now I see. Now, before doing this, we need to create another for loop. And why is that? Well, because we need to loop through the assets to make sure the asset contains a value. So we create another for loop. 0a less than result.data dot asset balances dot assets dot length a plus plus. Now we create the selected variable. This one contains result.data dot asset balances dot assets a. This is accessing every asset, and we will need that in a moment here. So now we do an if, and we say asset names found if the asset index of selected dot asset dot symbol, if the asset that we found, if the asset that we are checking here is in the asset names found. So if the asset that is shown here is existing already or not. If it doesn't exist yet, we will add it to the collection of the assets. Okay, it's actually equals -1. Else the asset already exists and we need to update the variable. So it could be that this asset is new, so we need to include it here like so, or it could be that the asset has been added previously and we need to update it with more blockchain data like that. Hope that's clear. I know it's confusing, but it will be very clear in a moment. Asset names found. We are going to create a new push to the assets found, and we're going to simply push the asset symbol there, because this means the asset has been found and we want to include it in the list of assets found. Now we're going to use the assets found. This is the main variable that contains everything, and we are gonna add all of this data. As you can see here, this is the data we want formatted, and we need it to be like that so that it's easily processable on the front end. So we do asset, we're pushing an an object that starts with asset and it contains a symbol. Selected.asset.symbol. Then we go to chains. This will be all the information for every chain. Chain IDs, I.name, so this is the Ethereum blockchain or others. Balance, I don't know what happened there. Anyway, balance, we go to selected.balance. This is the balance of the asset that we added here for Ethereum. So this will be Ethereum, and this will be like 1.2 Ether or something like that. Now that's for new assets. If the asset already exists, we do the following. We do the index. We try to find the asset position in the array. Remember, this is an array that contains every asset, and every asset contains an array with the chains and balances. So we are checking this thing here. We need to map the asset object. Dot asset dot symbol index of. I'm going fast because we need to do a lot of things. This is the best way to accomplish it all in a reasonable time frame. Symbol. Then we go ahead and update the asset by adding a new chain. Index.asset.chains.push. Remember, we're adding a new item to the array of chains. We're just simply gonna push an object that contains chain IDs, I.name, and balance, selected.balance. Now that's a lot, but this is ready right now. We are now getting all the information we need. So there's two loops. There are ways to improve this, but this is the easiest way for you to understand how this works. Assets found. This will let me log in all the assets found and the balances on every blockchain. Let me see if this works right now. Yeah, start server and see how it goes. Oh yeah, we need to return also the assets found, just that we will need it later on. Right now it's requesting all the assets for every blockchain and showing the information. Let me be clear with this. We are making a request to every asset for this account, and then we're going through every blockchain and seeing if this asset exists on every blockchain, and if so, add it to this list. That's what we're doing here. So you can see we have that assets found. We have all of these assets and all the different chains with the balances. That's excellent. So now we are gonna reactivate the server. I'm gonna put this down here. Wait a minute, because we will use it like that. Now we're gonna create an endpoint called asset balances, and we're gonna pass a parameter here called wallet. This is gonna be an async query, and it's gonna take a request and a response. Now we simply get the assets found. Assets found is equal this thing, and we're gonna make an await, and we're gonna make a request, and instead of using this address, we're gonna pass the request params wallet. We're gonna pass this thing so that when people make a request to asset balances / the wallet address, we are executing this function with the wallet address. All right, Now let's return the response that send JSON.stringify assets found. All right, that's great. We are pretty much ready. We need one more query, one more getter for the server here, and it's gonna be /request response, and this we are gonna simply return a render of index. This is gonna render the index.egs file. That's basically the HTML file that we will need. Okay, we have this ready. Now that the server is ready, let's start coding the index EGS, and for that we need a folder called views, because EGS stores the pages in views. I'm doing it HTML5. Wait a second. Views, and we're gonna call it my DeFi dashboard. Then we will need a few things. We will set up let's start with just this basic design. We are gonna add this later on. So let's start with the title, h1 call title, and let's call it my DeFi dashboard. This is gonna have a class title, and then we're gonna add some messages. They're gonna be connect message, and it's gonna be connect wallet to see your assets, and then a message that says loading assets. This may take a while. Checking 35 blockchains. This is so people know that it's gonna take a while. And then we create a UL with the ID asset container. This will contain all the assets, and then finally we import the build.js created by Webpack. Alright, the server is serving the dist folder, Webpack is doing that. Alright, let's run this. Let's see how that looks like. But before that, we need to update the package JSON with a few scripts. Let me show you how this looks like. We need to create a script called compile, and that's gonna be npx webpack. Another one called watch, which is gonna watch for changes on the front end with webpack dash watch, and a start, which is gonna run both watch and server at the same time. That's why we need npm run all parallel watch server. Now we can stop this and we can do yarn start. You see, start will run webpack. Let me show you what's going on. Will run webpack. You can see it created a dist folder with the build, and it started the server here by running this script so that we can use the imports with bubble rc. So now we can go to localhost 8000 and see the basic design we've created. This is the EGS file that's been rendered through the server, and it's importing the build.js file. So now let's improve this. Let's make a proper looking website, and for that we need style. Check this out. Yes. So yeah, when it comes to the style, I'll go through very fast because this is pretty standard stuff. Just making the website look good. That's all I'm doing here. Style, type, none. We're gonna use an asset later on. Color, white smoke. Padding 10 pixels. Border radius 20 pixels. Margin bottom 10 pixels. Solid gray. The asset container will have a padding left of 0, max width of 500 pixels, margin auto. The header will have a display flex, justify content center, align items center, and a gap of 30 pixels. The title, text align center. Loading assets message will have text align center and a display none, so that we don't want to see this at loading when the website loads. Connect message have a text align center, and we create some media queries for smaller devices so that they look great. Max width 600 px. Dot header gap 10 pixels. Flex direction column and a font size of 10 pt. That's all when it comes to style. Let's go ahead and work on the JavaScript for the front end, and that's in the index.js file. Let me load that and see how it looks like. All right, we're gonna use a few things. We're gonna go right away with the model also. Let me add that thing here. We're gonna add this model here for connecting your wallet. So we are gonna create a header here on top of the title. I'm gonna call it header. It's gonna have a div wallet, and this is important. This is from Web3 model. This should be called like that, Web3 model. Well, I think this is not being used, so we can remove that. Now that that is in place, we are gonna go to our script file, which is here, and this is imported through the build file. We are gonna write a lot of code here, so let's start with the imports. We're gonna need the chain, configure chains, create client from WAGMI core. I'm gonna import client ctrl config ctrl from Web3 model /core and import Ethereum client model connectors and wallet connector provider. I know this is confusing, but you just need to do it. So we're gonna create a listener window, out-of-band listener, that will listen for the load event. Once it's loaded, we are gonna set up wallets. I'm gonna set up the wallet, and this is so that we can access the wallet. It's gonna be in a sync function, and we're gonna do a few steps. This is strictly so that people can log in to their wallet. Okay, so now I have the project ID and I can access it. This is simply the project ID from Infura or whatever. So we need to use chain.mainnet. Then we set up the provider. This is very, you need to follow these steps as I'm showing you here. It doesn't make any sense, but that's just the way this library, the Web3 model, works. Wallet connector provider. It's called Wallet Connect provider. We pass the project ID. Then we create the WalkMe client. Create client. Out connect true connectors, model connectors, and we're gonna pass the app name, Web3 model, and the chains, then the provider that we just created. Okay, we need a comma here. Then we create the Ethereum client. And we're gonna pass the WalkMe client and the chains. Then we do the config control dot set config project ID. Not explaining you how this works because it's not very specific, but you can make some changes to this. You can change the theme. In fact, let me do it white or TL. You can change basically the color of the connector accent so that people can choose the wallets with a different style. This is strictly so that people can connect their wallet and they can access the blockchain address. That's all we need. We need the blockchain address for requesting the assets, and we're going to allow people to use any connector they want to. It can be MetaMask, it can be Wallet Connect, it can be many different things. Let's do watch account. This is the important step, because this function, what it does is it watches for changes to your account. So when you connect your wallet, it detects and executes this function. After that, we need to await import Web3 model UI. We need to import the UI, which is when it is shown. The UI is shown when we import it here. The button, the connect wallet button, is shown when we import it here, and this is after all the configuration. So we are gonna do a few things here. I'm gonna, if there's a change in address, we're gonna do get assets with the address. That's when the address is detected, we are getting the assets, and we are creating a function that's called get assets. This is the function that will make a call to the server and is gonna request all the assets in this format by calling, let me show you, by calling the endpoint asset balances and passing the wallet address there. So before doing that, let me do a few UI changes that will happen when it comes to the messages, the loading messages. And we're going to use document query selector, wallet, inner HTML, change address or empty. If there is no address, just show an empty string. Now here we're gonna do the same thing, document query selector, and we're gonna select the asset container. The asset container is the one, this one is the list of items where all the items will be shown. This is a dot inner HTML, and this is gonna be empty every time the address changes. It should be empty. Then we change this to loading message, loading assets. It's called loading assets, right? Yeah. This message we want to show it. We want to display it. Style.display. I'm gonna do inherit, and the connect message. This connect message, connect wallet. This is gonna be hidden once we detect a new address. After the assets are loaded, we're gonna hide both of these ones, none. Well, since that one is hidden, we just need this one. And then if we don't detect an address, or if the wallet is disconnected, we are gonna do the same thing with messages. We're gonna refresh the container. We're gonna remove all the assets here. We're gonna hide all of these ones, and we're gonna show the message connect wallet. That when people disconnect, we want to do that. So it's gonna be none. We're gonna remove the message, the loading message, and we're gonna do a display inherit here, which will show the message that we had before, the connect wallet message. Okay, now that is done, we can, well, let me hide this so you can see how this works. Now this should be working. So let me restart the server and webpack. Yeah, now this is loaded, and this should have a better design, you see. And this is set up. For some reason the wallet, the connector button is not shown. Let me see why. Foreground. Let me check this real quick. Chain, mainnet, project ID. Config, client. Well, this is unnecessary. Create client, WACME core, WACME model core. We go here, provider, configure chains. Yes. To connect through connectors, model connectors. Ethereum client, we pass the WACME client and the chains. Then we do the config, project ID, theme to dark, default, so the Ethereum client. Yeah, this should be working right now. Refresh this. Okay, yes, you can see the button is there. We can disconnect it, and we can connect the wallet. Let me click on this, and you can see here it is loaded. Let me close this. Let me change the color to white. I believe it's white or light or something like that. It should be refreshing. It's refreshing the changes with Webpack. Okay, white doesn't work, so let's do light. Webpack is refreshing. The build, yeah, there you go. You can click on connect and you can see the light design. You can click on MetaMask and it will show the MetaMask address that we are using. See, all right, now it's connected. Let me close this here, and you can see the address that I connected here and the disconnect button. This is the Web3 model, and it is working. Now we are gonna implement this function, and this function will make a request, like I said, to the server, and it's gonna show all the assets. So let's do that. Let's create a function, I mean a message. Starting to get assets, just for login purposes we need that. With a response, and we're gonna do a fetch to asset balances. Wait a minute, this should be like that. And we are gonna pass the wallet address here. Then this is simply a request. Let me show you again, just to make it clear. This is a request to this endpoint, which gets the balances and sends to the user that. So now we do res again, await response.json, console log, assets received. And now that we received the information of the assets, we need to show it properly. For that we are going to use a for loop. Res.length I++. Response is the assets, an array of assets. So we do a change array, response I dot asset dot change dot map item. So what we're going to do is we are going to create a list element, li element, and we're going to put that on the HTML. So we do li, close this, and we're going to show the item.chain colon. So yeah, the asset.chain, item.balance, and the symbol res I asset symbol. You're gonna see how this looks like in a moment. So yeah, that's the thing. Okay, we're gonna close this here, and we're gonna do a query selector. We're gonna put all of the assets inside here, inside this list, asset container. Selector asset container dot inner HTML, or rather insert adjacent HTML. This is before end. This is so we can add new items below the existing items. I'm gonna pass like that. We're gonna have a list. By the way, this is, you see, UL, we need a list of i's, like that. And then class will be asset. We need the class there. So now we pass a bold tag with the response. I.asset.symbol. This is the symbol here. We need to create a new UL with the chain array. This is the chains and the balances, and we join that with an empty space. Alright, that's the function, and this function makes a request and it processes all the items the right way. Alright, we can execute this and see how that looks like. This is refreshed. We just reload the page, and now the wallet is connected and it's loading from the server. You see starting requests here. It made a request, a get request to asset balances, and it passed the address here at this time. It's starting the requests. This will take a while because it's a lot to process. It's checking every asset on every blockchain, every asset you have, and that is formatted and sent to the user like so. This is to the client. This is gonna take a while. Let me see the console here. Okay, there you go. You see, we're getting all the assets. We have 8 USD on this blockchain. We have Ethereum on Ethereum blockchain, on the Arbitrum blockchain, and we have the amounts properly shown there. Now if I were to change the wallet, if I were to go to this account, I simply click on connect, and this detects the change. Remember, we are using this function, the Ethereum client.watch account. This one detects the change in account and it refreshes. It executes this and it gets the assets again. It takes a while, but it works. So yeah, let's wait for this. So yeah, that should be it. In fact, you have now a working program, a working DeFi dashboard that shows you all of your assets grouped by blockchains. So you can see how much of each asset you have on every blockchain in a very nice way, so that you can simply check how much there is. All of these are a bit spammy. The IOV, this one, I don't know what that is. There's some spam tokens that have been sent to me. So yeah, this works, and now you can play around with it. You can disconnect it, you can connect it again with many different wallets, and it's gonna work every time. It's a very robust application, very simple. It's using vanilla JavaScript and a Node.js server. Hope you found this useful. Hope you now understand how to work with the DeFi Yields API, how to make requests with the playground, how to build an application from scratch with Webpack, Node.js, Babel, EGS, and vanilla JavaScript. That should be it. The code will be available in the description. Hope you enjoyed. See you around. Have a great day.